Hello and welcome to People Online. This is the first of a series of videos on common statistical tools for HR analytics. The topic for today's presentation is correlation and regression. Contents. In this presentation, we will be covering what is correlation, correlation coefficient, three popular correlation coefficients, and what is regression. What is correlation analysis? Correlation analysis involves understanding the relationship, if at all any, between two variables. If one changes, does the other change in a similar way or in a dissimilar way or doesn't change at all? For example, one may wish to examine the relationship between salary and number of years of experience for employees with similar qualification in an organization. What is correlation coefficient? Correlation coefficient measures the strength of the correlation. Typically, correlation coefficients vary between +1 and -1. +1 would indicate the perfect positive correlation, implying that if one variable increases, the other would increase in a similar manner. -1 would indicate the perfect negative correlation, implying that if one variable increases, the other would decrease in a similar manner. 0 would indicate lack of correlation, implying that if one variable changes, there would be no effect on the other variable. Needless to say, higher the value, better would be the correlation. For example, 0.8 would mean a stronger relationship than what is implied by a value of 0.67. Three popular correlation coefficients. These are Pearson's product moment correlation. Here, both variables must be continuous. Spearman's rank order correlation and Kendall's tau. Both variables are ranks here. Phi coefficient. Both variables are categorical. Pearson's product moment correlation. Pearson's product moment correlation is a measure of the linear correlation between two variables that are continuous. It shows the linear relationship between two sets of data. In simple terms, it answers the question, can I draw a line graph to represent the data? Two letters are used to represent the Pearson correlation. The Greek letter rho for a population and the letter R for a sample. The coefficient is given by the formula R is equal to n sigma xy minus sigma x into sigma y divided by square root, and inside you have n into sigma x square minus sigma x square, and this is multiplied by n into sigma y square minus sigma y square thereof. Here x and y represent the two sets of data and n the number of data sets that we are dealing with. An application. We have data about experience and salary for 10 people. They're codenamed A to J. They're all professional degree holders. Is there a correlation between salary and experience? And can we use product moment correlation coefficient to get an idea about this relationship? Well, the answer is definitely yes. Okay, so you can see on the leftmost column the names are there. Then you have the two variables, experience and salary, they're both continuous variables, and hence we can definitely apply product moment correlation coefficient. In a video, in a separate video, we would be showing Excel tutorials as to how to, compute product moment correlation coefficient when you have similar data. Spearman's rank correlation. The Spearman's rank correlation coefficient is a statistical measure that examines the degree to which two datasets are correlated, if at all. The dataset here would comprise of ranks. The data is paired, showing the ranks in two different assessments for each element. The coefficient is given by the formula. The coefficient is equal to sigma of xi minus x bar into yi minus y bar, and in the new denominator you have square root of xi minus x bar square into yi minus y bar square. Where there are no tied ranks, a simplified version of the formula to use is 1 minus 6 sigma di square divided by n into n square minus 1, where d is the difference in paired ranks and n the number of data points. An application. We have data on the results of two assessment tests for 10 people. The test scores are X and Y. Ranking has been done for both test scores, so each individual has two sets of ranks, so totally there are 10 data points. Can we work out Spearman's rank correlation coefficient? Well, the answer, needless to say, is yes. In fact, this is a very typical scenario where we can use Spearman's rank correlation coefficient. And in the same series, in a separate video, we would be showing an Excel tutorial on how to compute Spearman's rank correlation coefficient. Phi correlation coefficient. The phi coefficient is a measure of association between two binary variables, for example, living versus dead, black versus white, success versus failure. It is also called the Yule phi or mean square contingency coefficient and is used for contingency tables when at least one variable is a nominal variable, both variables are dichotomous variables, and the coefficient is given by the formula phi is equal to square root of chi square by number of data points. So we need to compute chi square and divide that value by the number of data points, which is n, and take a square root, and we'll come to the phi correlation coefficient. And chi square is basically the sigma of observed minus expected frequency, square thereof, divided by the expected frequency. Let us see an application. We have data about experience and salary for 50 graduate engineering trainees working in a company. 10 trainees were hired from the NITs and the rest from other colleges. At the end of the year, they were all assessed and performance ratings arrived at. There were two kinds of rating, excellent and adequate. The table below shows the appraisal results for the two groups. So we could see here that out of the 10 people recruited from NITs, 8 got uh, an excellent rating, whereas the 40 people who got hired from other engineering colleges, 12 got an excellent rating. So from this distribution, can we conclude whether there is a correlation between being an NITian and getting an exemplary rating. And can phi coefficient help us to measure this correlation? The answer is yes. And in a subsequent video in this series, we would be doing an Excel tutorial where we would show you how to compute phi coefficient. Regression analysis. Regression is an equation that tries to best represent the relationship between variables. Linear regression. Regression analysis is a set of statistical processes for estimating the relationships between a dependent variable and one or more independent variables. The most common form of regression analysis is linear regression, also the most simple, or I would say the simplest form of regression, involving only one independent variable in which a researcher finds the line that most closely fits the data according to a specific mathematical criterion. Coefficient of regression and coefficient of determination. If the regression is y is equal to mx plus c, m is called the coefficient of regression, which signifies the impact of change in one variable on the other. R square is the coefficient of determination indicating the goodness of fit, where R is the correlation coefficient. Let us see an application. We have data about experience and salary for 10 people, codenamed A to J. They're all professional degree holders. Can we set up a regression connecting salary and experience? So this is how the data looks like. So we have two variables, experience and salary. So we can uh, create an equation such that we put in the experience, we get the salary, or we put in the salary, we get the experience. Yes, it's absolutely possible. And we would cover this in a separate video in the same series, wherein we would use Excel and show you how to do this. Summary. In this presentation, we have covered what is correlation, what is correlation coefficient, three popular correlation coefficients, and what is regression. Thank you for watching. If you found the video to be useful, do like, share, and subscribe. Press the bell icon to stay tuned in for the next video in this series. Until then, goodbye.